Okay, today we're going to talk about oxidation numbers. Okay, oxidation numbers. So we're going to start off with our learning target, which is to state the significance of a chemical formula, and using the chemical formula, write the name of a chemical compound, and using the name of the compound, write the chemical formula. So those are the same learning targets we've been dealing with. Now, our success criteria for today is that I can state the oxidation numbers of compounds, and I can state the rules governing the oxidation numbers. I just passed out to you oxidation number rules. So we're going to start by looking at these rules. Rule number 1 states that the oxidation number of an atom in its elemental form is always 0. So if I have a single element like I have right here, Br, even though there are 2 bromines, it does not matter. That oxidation number is still 0. So even though there are 2 of them, the oxidation number is 0. Could there be 5 of them? Yes. Oxidation number would still be 0. Rule number 2 states that the more electronegative element in a binary molecular compound is assigned the number equal to the negative charge it would have as an anion. So I guess we're going to need our periodic table. So take out your periodic table. As I am looking at these 2, carbon and chlorine, I'm looking at these 2 and I say, all righty, what is the more electronegative? Well, the electronegativity for carbon is 2.55. Electronegativity for chlorine is 3.16. So chlorine is the more electronegative element. So as I am looking at the chlorine here, I am going to say it is going to take the charge it would if it were an anion. So what charge would that be? Well, chlorine is a halogen, so it's 1 away from having its octet, so it's going to take a -1 charge. So in this case, chlorine would be -1. Now, how do I figure out what the carbon is? Well, it's got to equal 0. So if I have -1 and there are 4 chlorines, that's going to give me a -4. So what completes this equation? +4. So my carbon must be +4 in this particular instance. So if we have a binary, a binary molecular compound, we need to check the electronegativities. Rule number 3 states the oxidation number of a monoatomic ion is equal to the charge. Okay, so this is just saying if I have ions here. So this manganese has a +6 charge, so its oxidation number is going to be 6. The sulfur is a -2 charge, so its oxidation number is going to be -2. Rule number 4 states that the oxidation number of all group 1A metals is +1. So the alkali metals, group 1 metals, are all +1 unless they are by themselves. Unless they're in their elemental form, then it would be 0. Revert back to rule number 1. Okay? So rule number 4 says that all group 1 metals are +1. Rule number 5 states that all group 2A metals. So the alkaline earth metals are all going to be +2 unless they are in their elemental form. So all group 2 metals are +2. Rule number 6 says that hydrogen has 2 possible oxidation numbers. It can either be +1 or -1. Well, how do we tell? Well, when it is bonded with a nonmetal, it is +1. When hydrogen is bonded with a metal, it is -1. So if we were looking at these right here, following my rules, okay, hydrogen here is with the nonmetal, so this is going to be +1. So oxygen here is -2. Here I can see that the hydrogen is with a metal, so that means it's going to be -1. That means that strontium is going to be +2. But we knew that that strontium would be +2 because of the rule we just had. Rule number 5 said that alkaline earth metals were +2. And strontium is a group 2 metal right here on periodic table number 38. So rule number 6 is dealing with hydrogen, whether it's a +1 or a -1. Probably the majority of the time, folks, you're going to see the hydrogen is going to be a +1. Okay, we don't see it too often bonded with a metal, but we could. Rule number 7 is dealing with oxygen. Oxygen has 2 possible oxidation numbers. It can be -1 if it's a peroxide. Okay? If it's peroxide, it is -1. That is pretty uncommon. Okay? But Na2O2, that is a peroxide. Okay, the peroxide is this little O2 right here, 2-. Probably the most common ones you're going to see, lithium oxide, sodium, or lithium peroxide, sodium peroxide. How about hydrogen peroxide? You've heard of that, haven't you? Hydrogen peroxide. Okay, so those are the most common ones you're going to see, and they're all dealing with alkali metals and hydrogen, so to speak. So you just have to recognize when you have a peroxide. Okay, so I look at this one right here, knowing that I have a peroxide. That's going to give me a -1 for there, so my total is -2. This sodium has got to have a +2, so each sodium has got to be a -1 oxidation number. Now, if I look at this other one, Fe2O3, this is not dealing with the peroxide, so that's going to tell me that this oxygen is -2. So my total charge is -6 right there. So my total positive has to be +6. So each iron has got to be +3 oxidation number. So oxygen has 2 possible ones. It can be -1 in peroxides, and I say there, that's pretty uncommon. The most common one you're going to get for oxygen is going to be -2. Rule number 8 states that the oxidation number of fluorine is always going to be -1. Okay? Why is that the case? Well, isn't fluorine the most electronegative element? Okay? Yes, it is. So it's always going to be -1. Rule number 9 says that the sum of the oxidation numbers of all atoms or ions in a neutral compound is equal to 0. So the sum of the oxidation numbers is equal to 0. And finally, the sum of the oxidation numbers in all atoms in a polyatomic ion equals the charge. Okay? So here I have PO3, the phosphite ion, and it has a -3 charge. So as I am looking at this, okay, I look and I follow my rules and I get my steps and I say, okay, I'm going to start out with this oxygen there. Is that oxygen or peroxide? It is not. So I know that that oxygen's charge is going to be -2, okay? So that gives me -6. Now, the sum of all of these has to be equal to -3. So what completes this equation? How about a +3? So my phosphorus there is +3 because it has to equal the -3. Questions on that? So when we have a charge, okay, of a polyatomic, it's got to equal what that polyatomic's charge is. Now, here are a couple we're going to work on, okay? We're going to work on these and do these, a couple slides worth of oxidation numbers. So I look at SO4 here, 2-. That is the sulfate ion. So as I go through and look at this, I say, okay, I'm going to start out with my oxygen. Is that oxygen a peroxide? It is not, okay? So I know that this oxygen is going to be a -2. So that gives me a -8 total charge. Since it is an ion, it has to equal the charge, -2. So to complete this equation, I'm going to get a +6. +6 -8 gives me a -2. So my oxidation number for sulfur is +6. For oxygen is -2. Now, looking at the second one here, NO2. Now, is this a peroxide? It says O2, but is it a peroxide? It is not. Remember, I told you the most common ones that you're going to see the peroxides are Li2O2, Na2O2, and H2O2. So this is not a peroxide. So that's a -2 there. So that gives me a total of -4. It's got to equal 0. So I have to have a +4. So now I know that my nitrogen is +4. Now my final one over here on the left, NO, just another version of nitrogen and oxygen bonded together. Is nitrogen there is oxygen a peroxide here? It is not. So oxygen's going to be -2. And that means that my nitrogen has got to be +2 because it's got to equal 0. We okay with those three? Okay, now we get a little bit more complicated, okay? A little bit more complicated because we have multiple ones of these. So I look at this first one, okay? Look at my first one here and follow my rules, okay? Follow my rules. I'm looking here at oxygen. Oxygen is not a peroxide, so that's going to be -2. So that's going to give me -8 for the oxygens. My next rule, I know that potassium is an alkali metal. It's a group 1 metal. So that is rule number 4. Rule number 4 states that all group 1 metals have a +1. So, +3. So what's going to fill this in? Okay, +3 -8. What's going to give me 0? Well, it's got to be +5, right? So that phosphorus there is going to be +5.
Teachers, please pardon this interruption, but if any of the following students...
What was your question, Will? Okay, I would agree with that. Are we dealing here with, we have a compound, though. We don't have just a polyatomic ion, okay? So even though you're right that would be a +3 charge, but there's the 3 that's going to counteract with that. Okay? Now let's look at the middle one here, Li2O2. Let's start off with the oxygen. Do I have a peroxide here? I do have a peroxide, right? So that's one of them I told you to look for. So that tells me that that oxygen is going to be -1. So a -2 total. So lithium has to be +2. There are 2 of them. So lithium is going to be +1 in this instance. Now this last one is really a tough one. And I'm going to show you how I do this, because we have 4 different things here. So the way I do this is I break them down. I know that NH4 is a 1+ charge, don't I? I know that from my ion sheet. So NH4 is a 1+ charge. I know that SO3 is a 2- charge, right? So I'm going to do those individually as ions. I look here and I say, okay, is hydrogen with a metal? Is hydrogen with a metal? It is not. Okay? So this hydrogen is going to be +1. Well, that means to me now that that nitrogen's got to be -3. So I can put that in -3. I can put that in +1. Then I break it down and come over here. Okay? Do I have a peroxide? SO3 2-. Is that a peroxide? Is oxygen a peroxide there? No, it is not. So that oxygen's going to be -2. So -6. So all got to equal -2. So that tells me that that sulfur's got to be +4. So that's the way I would do that one. I would break those both into the polyatomic ions and do them as ions. Any questions on that one? Any questions on oxidation numbers? You think you can do them? Okay. Yeah, Ashton? This one? The 2. Oh, this? Okay, this is just, okay, that number is just so they're equal to 0 in charge-wise. Okay, because ammonium is a +1, so you need 2 ammoniums to get to -2 of the sulfite. Any other questions? Okay.